Welcome, thank you for joining us. We're going to spend probably 45 minutes to an hour talking about the Selenium page object model. Okay, and maybe the first thing to understand, it's not specific to Selenium, but certainly Selenium is probably where it's most commonly associated. Okay, so in terms of agenda, we'll start by looking at really the definition, what is this page object model that we hear so much about, and the intention, why do we want to consider using this type of model for our automation testing, okay, for our UI automation testing. Later on in the session, we will definitely look at some working examples in both Ruby and JavaScript. And as we step through the layers of the framework, we'll come to understand the use of page classes for our page objects. And then within those page classes, we'll start looking at the use of methods for kind of simulating user actions effectively on your application under test, as we either navigate through the application or use WebDriver to drive the application, maybe check state on elements, assert for things being the correct state, or making an assertion for the presence or the existence of something. And then we'll look at some good ways to actually define these UI elements. All right, so WebDriver offers you 6, 7, 8 different ways of actually hooking into UI elements within your application. And some of those simply are better than others in terms of, if you've got a choice of 2 methods to use to identify your element, some are most definitely preferable than others in order to do that. So we'll look at some kind of best practice for element definition. And then we'll talk about some dynamic assertions. We'll look at a few types of assertions, but dynamic assertions where we're actually passing something of our own choosing through the layers of the framework to an assertion by way of asserting. It could be a positive check, a negative check, but a very useful tool within your automation. And then the idea of having a library effectively of helper methods that can be called upon from anywhere within the framework for common things that you need to do within your testing automation. But we structure these, we store these in a particular location because they help us to keep the code nice and clean and nice and maintainable. So we'll look at some good examples of how we do that. Okay, so yeah, thanks for joining, and let's start by looking at what the page object model actually is. So let's actually dig into what this page object model is all about. Okay, so firstly, let's understand that this didn't come directly to us from Selenium. Okay, so it actually came about through a chap called Martin Fowler. Okay, so he wrote a book called Refactoring, Improving the Design of Existing Code. This came out in about 1999, I believe. So, we're talking about a model that's been around for kind of over 20 years now. But the premise of what it's preaching absolutely still holds true to this day. Okay, it's still a very, very valuable model. The definition on the left there is what we actually take from the Selenium website itself. Okay, so links at the bottom there, so you can go and read about this in more detail at selenium.dev or on martinfowler.com. Okay, so really those to me are the 2 Bibles of kind of understanding what this is all about. But essentially, this is a design pattern for your test automation project. Okay, so we're going to assume that you're working with a web application, you're using Selenium WebDriver. Okay, and this is going to apply whether you're using Java, Python, Ruby. It's language agnostic. Okay, so the rules or the model absolutely apply. So this is all about understanding that within your web apps UI, you are using WebDriver to interact with that application. Okay, there are areas within that application where your tests on WebDriver are interacting, and that's either because you're driving the user journey through that page, in order to undertake that user journey, or because you are looking to extract some information from that page. There's maybe a text value that you're looking to capture from an element, or you're looking to assert the presence or the existence of something, a UI element on that page. Okay, and what this model essentially is, it's the recreation, or the representation, I should say, of your application under test within your automation project. All right, so we say here, a page object only models these as objects within the test code. Okay, so if we've got a home page on our web application, we will have a representative home page or home page class within our automation project. Okay, if we're on an e-commerce website and there's a product page, or what's known as a product detail page, that would be a logical candidate for us to have a representative product detail page within our automation project. Okay, so that's kind of the mapping or the representation that we're talking about. All right, why does this model exist? Why do we use it? And we'll come on to the core benefits in a bit more detail shortly. But essentially, this is about reducing code duplication. Okay, we should still think of test automation code as production code, right? Any coded automation that we invest in as an organization, as a team, ultimately it has a job to do, and it has to do that job consistently and reliably. And as a delivery team, you have to be able to rely on your automated tests. So the quality of the code that is running those tests should be taken seriously. Okay, so code duplication is absolutely something we're looking to eradicate. Okay. Ultimately, when things change or break in the UI, it could be an intentional change with future iterations of development, subsequent sprints in an agile cycle, or of course it could be a bug, it could be a regression. Okay, the idea of the page object model is that you have a single place or a single element on a single page as the place you need to go to address any potential changes that you need to make. Okay. Conversely, what's the opposite of that? You are not going to have to look around 30, 40 tests of where you have duplicate code and you have an element that's been represented 30 or 40 times duplicated across multiple tests. By using this model, you reduce that code duplication, and you ensure you have a single place to go to fix things when they do break, intentionally or otherwise, within the UI. Okay, so it is a design pattern. That's exactly what it is. Okay, heavily adopted by the Selenium community, as we say, over 20 years ago now. But still, that the underlying message, the value of it, the reason we use it, that hasn't changed at all. All right. So in programming terms, yes, this is object oriented. All right, as we say, it represents the application under test within our automation project. And then, as we can see there from the Selenium website, the tests then use the methods of these page objects whenever they need to interact with the UI of that page. All right. So again, coming back to our e-commerce analogy, I'm on a product detail page. There'll be something that I can only do on that product detail page, such as read more information about that particular product, or such as adding that product to cart, for example. I can likely only do those things from that product detail page. So those would sit there as user actions or methods, if you like, within my product detail page class within my automation project. Okay, so the overarching benefit here is a massive reduction of code duplication. But understanding that when the UI changes, the tests themselves don't need to change. We fix things either at the method or the element level, but the tests, the user journey through the application, can remain as it was originally designed. Okay, so that's in a nutshell. That's exactly what the Selenium page object model. As I say, it's not from Selenium, defined by Martin Fowler, but largely adopted by the Selenium community over 20 years ago, and other frameworks as well. So this isn't just for Selenium. Again, language agnostic. All right, so yeah, that's what it's all about. Okay, let's start looking at some of this at a code level. Okay, so I'm going to start with a Ruby project. Okay, important to note here that within Test Evolve we also use Cucumber. Okay, so at the top layer of the framework is what we call the business facing layer. You have these BDD features and scenarios. Okay, but really for the importance of what we're talking about here, I have 3 versions of exactly the same test. Okay, so I'm just going to run a version of this test. They all do exactly the same thing. But to varying levels of either having implemented the page object model or maybe only partially or not at all. The test will run exactly the same way. We'll watch it once and then we'll look at the actual implementations of these. Okay, so let's run this. We're looking at an Amazon checkout flow. We don't go all the way to completion, but we get the product in the cart and we begin that checkout flow. All right, so we open up Chrome, WebDriver. It's going to load the Amazon URL. We search for a deck chair. We pick a product. We make some assertions on this page. We add it to basket. And then we begin that sign in and then that checkout flow. On this next page, we make a few basic assertions and then the test will complete. Okay, so that's essentially what we're looking at. So we're going to start to look at the code. The features, the scenarios are essentially all the same because the user journey is no different. Okay, and to start with, we're going to look at the kind of the bad implementation of this, where there is no reference to the page object model whatsoever. So if I click into these steps, let's just move this around and make things a little bigger. Okay. So because we have this Cucumber layer, effectively we have these given when then steps. They are like tests in themselves, if you like, but collectively, obviously the given when then, that comprises the whole user journey. That is the test. When we have no reference to a page object model whatsoever, we are really just, we are dealing with the browser and the browser's and WebDriver's direct interaction with the browser and the way in which it communicates to it. All right, so we have absolutely no reusability whatsoever. Okay, so let's just look at some of this. So we are directly instructing the browser to go to a particular URL. One of the things we did there were to clear the accept cookies banner if we saw that. So in Ruby terms, and again, you see how we've identified these elements. Okay, so we are looking for a span that has a text of accept cookies. And we're simply saying in Ruby terms, if that span exists, so if it's present, then click on that accept button to essentially make it go away. All right, what we do next is effectively run a search. Okay, so again, look at this straight away. We have 2 references to the search text field. Okay, this demonstrates the point perfectly. Okay, so if multiple testers on the project are all kind of working on different tests, but all of these tests include some kind of Amazon search, okay, and they use this approach, every one of them is going to have at least 2 references to this same UI element here. All right, now in the first instance we're clicking on it, and in the second instance we are setting a search term. All right, and the point of reusability, if this element hook or the way in which we identify this element were to change, you can start to see we are going to have multiple places in the code base where we would need to address that, where we would need to fix that. Okay, so you start to understand this concept. Well, certainly in this this version of the test, there is no page object model reference at all. There's no reusability. This could result in very, very brittle tests. There's no kind of there's no essence of sharing code or building blocks between developers or testers on your project. Okay, so we'll carry on going through, and you start to see similar concept. Here we are submitting the search. So this is a button with an ID of that, and we are clicking on that. And then we've got some assertions coming in for the first time. So once we've run that search, we are then running an assertion as within our test, to essentially make sure that that search returned a results page. Okay, so we're raising an error with an error message, and we're saying that the results section header was not present on the page before the timeout unless our means of asserting that was present. Okay, And our means of asserting that in this case was, again, a span with a class of this value here. So that's our first assertion, essentially, to make sure that a page is loaded. We have another type of assertion written in much the same way, looking for the actual product on that page. So specifically the product within that listings page. All right, so another assertion we're making there. And then we're selecting our product. So again, we're just instructing the browser via WebDriver to look for a span that has a text element of this, essentially the thing that we're looking for, the deck.j in question. All right, and we're then simply saying .click. Okay. Again, no reusability in any of this. This is a product on a results listings page. There's no way that any other developer tester on the project would be able to make use of this code. I think the other point I'd make here as well is that this is, whilst we have this kind of wrapper step here which describes what we're doing, in a framework, if maybe you're not using Cucumber and you're simply looking at lines of code that look like this, with enough experience and time on the project, you can probably understand what's going on here. But collectively, it doesn't read especially well either. Okay, so it's not the easiest thing to figure out what's going on. Okay, let's carry on stepping through. So as we move down, so this was the point at which we're selecting our product. What we're looking for here, we've got 3 steps, 3 assertions that are all checking effectively that we've moved onto a product details page. Okay, so the page for the product. Similar ways we're making these assertions. We're looking for spans or we're looking for buttons. Our locator strategy in this case is to use the ID of these things. Okay, so for example, we're looking at a button with an ID of the add to cart button, and we're making sure that these are present on the page as a means of determining that we've successfully landed on the product detail page. And then ultimately we click that add to cart button, of course, to add that product to cart. Okay, and then finally we have just an assertion here. That if I wanted to instigate the actual checkout flow, I need this button here. So it's a button with a name of proceed to retail checkout button. Again, another a perfectly valid assertion in terms of Ruby, but no reference to the page object model whatsoever, no reusability, very low on the readability, very high on the brittle score. Okay, so we've probably referenced 4, 5, 6 different elements here. Within a relatively short space within this test, but in any one of these changes, either through a bug or through an intentional change, you can definitely see how you are going to have multiple places in your tests, and that could just be for you as a single user. You may have multiple places. If you magnify that by the number of members of your team, maintainability is very, very low if you adopt this kind of approach. Okay, and then the third part of the test was I can check out. Okay, so we are essentially proceeding to the checkout flow by clicking on that button. What we are really doing here, we come to a sign-in screen. So we are interacting twice with the username or the email password. So we click on it to start with. And then we set or we send the details of the user. We then click on the continue button, at which point we're presented with a password field. We set the password credentials, and then we click on the sign in button. Okay, so this is a good example of kind of a component method. Okay, this is a service that particular page provides, is that sign in function. And yet in this particular way of running this test, again, we've got 2 references here to the username field. So if that broke, we'd have to fix it twice there. We've got reference to a password field. Again, you can see no reusability. Okay. And then finally, once we've signed in, we're taken to essentially the start of the checkout flow. And that's as far as this particular test goes. But you see, again, we've just got this idea of raising 3 assertions just to make sure that we are on the right page and that certain elements on that page are correct. So we're looking for a delivery address header. we were looking for a payment method, and we were looking for an order total. Okay, so the delivery address header, our locator strategy was an H1 in this case, and in this case we actually used an XPath reference. Okay, so we were checking for the presence of that. For the payment method, we were looking for an H3 attribute on the DOM that has a class of this. Again, we're checking for that to be present. And then finally, we're looking for the order total. Okay. We were looking for a span, and in this case that it had a text element of order total. So these are fairly kind of rudimentary checks, but these three checks in combination give us a good confirmation that as far as the flow of the test goes, we've ended up on the right page, and certain elements within that page are present as we expect them to be. But hopefully what you'll see here, that this is probably the most basic version of a kind of a WebDriver browser e-commerce checkout flow type of test. Okay, as we've said, very low scoring on the kind of the readability, very low scoring on maintainability. We've already seen several instances of kind of code duplication here, where we're effectively locating this element twice in 2 rows of code, and we've talked about the fact that if that breaks, we're going to have to fix it in both places. How you can start to extrapolate that up with the members of your team who are all writing tests if they're using the same excuse me, the same method. You can see how that maintainability is going to become a real problem. All right, so we will look at the next level up effectively. All right, so a next level up, or the first step to improve that workflow, would be to start to introduce the idea of the page objects, but we might not necessarily be using holistic methods for kind of complete functions on the page. All right, so what do I mean by that? Right, well, let's have a look. So we still start with our go to amazon.co.uk, and we still have our kind of conditional accept cookies banner message. But what we now start to see, if we look at this product, this step here, okay, this BDD, this cucumber step that's effectively running the search, okay, we start to see that it looks a lot cleaner actually. And the reason for that is because we've now introduced the idea of a home page within our automation project. So we have a home page on the application under test. The page object model tells us that we have a representative, or kind of a matching page class within our automation project. Okay, so in this case, we've now introduced that for the first time. And then what you'll see is that rather than dealing with specifically with WebDriver and WebDriver's direct integration with the browser at this level, we've now introduced the idea of a named element, a named UI element on the page. All right, so you can start to see now that this starts to read with a lot more clarity. All right, so we're on the home page, we're going to use the search field, and we're going to click in that search field. All right, same thing, home page, the search field, but this time we're going to set our search term to be deck chair, and then, as we all know from an Amazon search, the next thing we do is to hit that search submit button and hit click. So this is the first time where we start to see the introduction of a representative page class and elements on that page. All right, so before we go any further, let's just have a quick look at that. I'll look at my home page. So certainly in Ruby terms, this is what my home page class, my representative home page within the automation project that maps to the home page within the application under test, this is what it looks like. So it's doing a couple of things for me. It's the place where I'm going to come to define my elements. All right, so you remember in the first test we were talking directly about WebDriver and how it uses this type of convention to talk to an element within the browser, within the application. Okay, what we're doing now, we're still keeping that locator strategy, right? So we're still referring to it as a button. We're still using its ID attribute. and this is the value that we're looking for. But we're simply giving it a name now. We're calling this our search submit button. So forevermore in our tests, we will refer to search submit button as opposed to repeating this over and over again. Now, I'm sure what you can start to understand is that should something about this button change, we now just have a single place to come and fix the way in which we identify and hook into that element, okay? Because our tests will only ever talk about search submit button. Now, whether that's me as a single tester with multiple tests all referring to this search submit button, and again, then if it's a team of 5 or 6 people, but they'll all start to use this idea of home page and then search submit button. As a team, we still only have this one place to come and fix that element if and when it's going to change, and it will do, because this is obviously the nature of app development. Certainly in an agile delivery model with successive sprints, things are going to change rapidly. And that really does show the importance of just having to address this in a single place as opposed to 20, 30, 40, 50 places within the code base, which would have been the case with the previous example. All right. And then we have the similar thing for the search field. In this case, it was a text field with an ID of this. And we're just going to refer to it as search field. Okay. So that's the first kind of exposure to this, this page object model, how we define our elements within a home page. So this is our home page within our project. Okay. The other thing that we did was to bundle together the steps, or the 3 steps that effectively we'll show that in the next example. Actually, before I just do that, let's just step back. There we go. We were still running our search as 3 steps there. Okay, as we then moved on to the next page, okay, we've got some search results. So we are still making the same checks, okay? So the success criteria for our test, for all of these tests, is exactly the same. We're checking the same things on the same page, but this time, so we see the same assertion here, okay? We're still looking for that results section header. But this time, my assertion is using my specific page elements. Okay, so I now have a dedicated page in the automation project for the results listing page. Within that, I have an element called the results section header, and I'm checking that that's present. Okay, so let's just step in here. And there we can see is my results section header. Okay. You know, we're using, at this level, we're using the same locator strategy, but we've given it, or we've created our own page object for that thing. Okay. So we start to now see much greater reusability within these assertions as well within our tests. Okay. Less brittle. Okay. Single place to go should something about that UI element change. And then here's an example similar to the search submit button.click. When we were on the results listings page, we then declared, okay, here is my product and I want to click on that product. Okay, so the way in which it did that, we'll have a quick look. Here is my product, again using the same locator strategy here, but tying it to an element name of our choice. And that will be the element name that we forever refer to for the duration of that test. Okay. Cool. So we've got the same kind of 3 assertions there. And as you see, as we move through, you see we start to introduce page by page. All right. So we had results listings page. We've now landed on a product details page. All right. So that, of course, has its own page within our automation project. That page had an element called product title. That page also had an element called add to cart button, and I'm checking the presence of it. And that page also had the element, a buy now button element within the UI. All right. So at this level, this is a halfway house, if you like. This is a partial implementation of the page object model, but only really at the element level. Okay. So all I'm really doing is declaring my pages, my mapping pages from my project to the application under test, and then I'm declaring individual UI-based elements within those pages, so I can then either click on them or assert their presence or something else. Okay. Other than that, the script looks relatively the same, okay? But it certainly does start to read a little clearer now. All right, I'm sure we can all agree that if we look at these 3 steps here to execute a search, that's going to look much, much cleaner and more understandable than these 3 steps here to execute the same search. All right, so that's kind of the partial implementation and the benefits that we see there. Okay, as we just finally come on to the then step, the I can check out part of that test. So we have, again, another page now. We have a basket page. We have a checkout button on that basket page. We're clicking on that. And then our sign-in process is now that bit cleaner as well. It's still a 5-step process right now. So the email field, I'm clicking in that first. I'm setting text. I'm hitting that continue button. But we have these elements which make much more sense now. Again, if I went back to the then step of the previous one, this was what it looked like previously. Not nearly as understandable, not nearly as readable. Okay, so that's the main difference between no approach whatsoever and a kind of a partial approach where you are just working with page objects for the first time. All right, so what I want to show you now is really the kind of the definitive approach. Okay, I'm just going to come back here. So we're going to focus on this guy here now. And this actually was the test that I ran at the start of the process. The flow, the journey is exactly the same, okay? But what we're going to see now is a full implementation of this page object model, okay? With all of it tidied up, we're going to start to look at methods on page classes now, which is the other thing that we would use our page objects for. Really, it's going to do 2 things. It's going to tell you about the existence or the presence or the state of objects that are unique to that particular page in the application. The other thing your page object model should do for you is allow you to complete certain actions on that page, a sequence of events that represent a user activity, like a sign-in form, signing in, or like submitting a search, for example. All right, and that's one of the first things we're going to start to see. So I'm just going to talk briefly about helper methods as well. Okay, so what we've now got is our first helper method. All right, so rather than test evolve or te.browser.goto, I've created my first helper method. It just simply says visit, and then I just pass it the URL that I'm interested in. So this is a really good example of a helper method, as is now our clear cookies banner. All right, so this is now kind of much more readable. It's also done in the form of a helper method. So if I click on either one of these, it'll take us into a helper file, okay? And we have a defined method, again, written, authored in one single place. So really easy to update, maintain, refactor from a code maintenance point of view. But it also has some resiliency built in. So the basic one for here, this is this method is named visit. It's expecting to receive a URL, okay, which makes sense. And there you will see the actual code I had in the first version of the test. All right, so it's going to use that concept of testevolve.browser.goto URL. But what I've actually got around it as well is kind of something that helps us with some resiliency, if you like. This is UI automation. You know, can be flaky at times. That's the reality of working with UI-based automation. But you can see here what it's going to do. It's going to allow me up to 3 attempts to do that if it needs to. So if this is unsuccessful on the first attempt, it will try a second and a third. And it will also just allow a sleep of 1 second just between those retries. Okay, so it just gives you a little bit of resiliency within that. If we just drop back, the other thing we had was a helper method for clearing the cookies. Okay, so nice and readable, but if I step back into that, this too is within our helpers file. Okay, and again, it uses exactly the same code that I had in the first test. All right, but it just puts it in a central place that everyone on the team could make use of. The idea of clear cookies banner, you know, several people may need that in several different tests. There's now one bit of conditional logic that will do that for everybody if they need to do that, and it is conditional, right? So it's only going to try and click on that accept cookies button, if it's present, if it finds it there. All right. So that's just an introduction to the idea of helpers to kind of keep your code nice and clean, nice and maintainable. I've got a few other examples that we can use here. So we've got a method that we can call from anywhere in the code base that's just called current_URL. So that will return the URL of the present page that you're on. So that uses something called testevolve.browser.url. And then we can do some programmatic stuff, using Ruby here. So I've got a method here that will create me a random string, a random label. It's called random label. It's going to build me a random string. I can call that from anywhere in the code base. I might need that to insert as part of a randomized email address, for example, or a randomized search term. That might not make a great deal of sense, but it could be used in that way. So we're using some core Ruby to do that kind of thing. All right. This might be needed on occasion. All right. The idea of having something allowing you to quickly refresh the browser. Well, the lowest level of code for that is testevolve.browser.refresh. But I could now call refresh browser from wherever I want in the code base, and it will execute that. All right, so there's no limit to how, and when, and why you use these helper methods. But if it's something that you need, there's a good chance that someone else on the team is going to need it. So you can drop it into a helper file, and again, it's just a single place to actually fix that should you need to, if and when it changes. All right, here's one that looks at extracting some information from the cookies within the browser. All right, so it's just a bit of an introduction to helpers and how we use them. So let's just continue through our test. Okay, so what I wanted to show you was the first example of a method on a class, on a page class. So we're still talking about our home page, but now what we've done, we've consolidated, I think it was 3 lines of code that effected a search on the Amazon website into a single line here. All right, so we've now created a method called search for product within our homepage page class. All right, and we pass a value. Okay, so for now we're hard coding that value that we're passing through. But if we look at this method within our homepage page class, all right. So this is really the second thing that your page object model is going to allow you to do. It's we reference this here, right? This function, this is a service provided by that particular page within the application under test on the Amazon website. In this case, it allows you to search for a product. All right. So this is a perfectly valid way of using your page object model. So we've created this method, search for product. You can see that it's using both of these elements up here. So we're talking about search field here. So we wait for that to be present and then we click on it. Search field again. We still wait for that to be present and then we set our search term. So it's going to set the term item. Item is the value that this method would have received when this method was called. And then finally, we refer to our search submit button. We wait for that to be present and then we click on that. All right, so that is now our search for product method on our home page class. All right, so within this when step now, so this is our cucumber scenario, BDD scenario, and this simply says when I select a product. So we now start to see kind of terms like this or lines of code like this, and it's really become nice and readable now. So our view will always be that when you implement this page object model, you now start to have this level of the framework, a very, very readable, almost like a manual testing script. Okay. Now let's look at a couple of assertions here. Okay, so this is one of the core concepts of the page object model, is that really you should just be using it to present information about the state of an element on that page. But we try, the relatively purist approach to the page object model is to keep your assertions in your test itself, which is what this is here, but not on the page object itself, right? So what do I mean by that? Okay, well, this is actually a checkpoint, isn't it? All right, so I'm raising an error here, and the thing I'm checking here is that the results page was loaded effectively. Okay, So the way in which I'm using my page object model now to tell me about the state of this application. So we're looking at the results listings page, and I've declared a method on that that says, which simply says results returned. So I'm calling something. So we look at that in totality. So raise this error unless the results are returned on the results listings page. All right. So what does this look like then? So we click on results returned. It's a very simple method that's just going to return true or false. All right. So this is an example of where we have a method within our results listings page class that's going to return a Boolean, true or false, to answer the question effectively, have the results been returned? And in order to do that, we use our page objects. So results section header. So we're simply saying, if that's present, return true, otherwise return false. So we are using the page object here, and we are questioning the state or the existence of an individual UI element, and we're returning true or false. And that's, this is the type of use that the page object model would advocate. We are using the page object to answer questions about the state of certain things within the UI. And then within my test, which is here, I'm then raising an assertion off the basis of what it tells me, true or false. Okay, so we're doing exactly the same thing here. So we're saying raise an error unless my product is also displayed. And that's been done in exactly the same way. This is a separate method, and it's checking for the existence of a separate element, right? So we're simply saying if my product is present, return true, else return false. So this is how we use the page object model within our tests to assert the state, the correct state of certain things. Okay. Now, the way we've just looked at it there is what I'd call, the relatively kind of the purest way of doing it, okay? So let's just touch on this one. So on the product details page, we are asserting or making sure that the product detail is displayed. Okay, we've done it exactly the same way. Here's actually an example of where we are deeming that multiple conditions need to be true for us to return true within our product detail displayed method. All right, so I want the product title to be present. I want the add to cart button to be present, and I also want the buy now button to be present. If all of those things are true, then return true. Otherwise, if any one of those is not true, then we'll return false. Okay, so that's the kind of what we call the purest approach to using the page object model. There is an alternative version that we use a lot of the time as well. Okay, and in some ways it's slightly more flexible, but it does slightly cross that boundary of having assertions within your page object itself. This is doing exactly the same thing as this, but you can see here with this one, the error, the assertion that we're raising is within our test here. With this one, the assertion that we're going to raise is actually within what we've built here, which is a verification method. All right, so still on the product details page, but I've written a method that says verify the product detail was displayed. Okay, so let's have a look at that. So here was my original. Okay, so it checked that those three things had to be true for us to simply return true. This is a different way of doing it, but what you can see here, and this is where it slightly crosses the threshold of the kind of the purest page object model approach. And the reason for that is that I have this method, verify product detail displayed, but I've actually got my assertions within this method, within this page object, within this page class in my Ruby project. Okay. But what it's actually checking is it's still checking for the existence of the product title, as it is here, the add to cart button, as it is here, and the buy now button, as it is here. But this is slightly more flexible in the sense that if this guy here returns false, I don't necessarily know which part of that, whether it's the product title, the add to cart, or the buy now button. I don't know which part of that failed. And that's what makes this one slightly more flexible, because I've got three independent assertions, but because they're independent assertions, I can add a unique error message to each one of those. So if one of those is not true, is not present, it's going to fail and tell me exactly which one was the problem. Okay, so these are two different ways of effectively checking exactly the same thing. This one here is what I would say is slightly more of a purist page object model approach. All right, this I think personally still sits perfectly fine within the page object because it's still telling me about the state of objects on that page. Okay, so these are simple assertions, but I have a bit more flexibility, and what it's going to tell me in the event of failure is going to be more meaningful, I would say. All right, so that's what we kind of refer to as the alternative form. Okay, when I ran that test earlier, it ran this version, the purist version, but it also ran this right next to it, and they both returned true. Okay. All right, so let's just check a couple more. So again, using that purist form, so we raise an error unless the basket is displayed on our basket page. Okay, exactly the same means of just returning true or false depending on the state of that object. Okay, and there's the alternative form for that, verify that the basket is displayed. Okay, so we can also do other things. We can log information to the console as well. So in the event that this error wasn't thrown and it moves successfully past that, then I can log some extra information to say, yep, I found the checkout button successfully. Everything is good. Okay, and then just moving down, the then step, exactly the same concepts. One more example here of where we've consolidated, I think 5 steps of our sign-in form into a single method here. Okay, so again, here's a new page, our sign-in page. So this maps to the sign-in page within the Amazon website. So we have a mapping or representative page class, page object within our project. And on that, I've now built a login user method. So yeah, as you can see, this is actually picking up 5 lines of code into a completely a sensible method that you would have on this page, right? So again, when we're talking about the page object model, we've said that we're either using it to confirm page or object state to us, as we've seen several times, or we're using it to invoke, or to exercise a service that is provided by that page or that component. All right. So on this particular page, the sign-in page, obviously one of the services that it provides to you as a user is the ability to log in. Okay, so because of that, I've created a login user method within my representative page class within my automation project. So we looked at what this was doing earlier. So, and again, it's using our page elements that we've defined up here. All right, so it's using those. So again, if something goes wrong with those, I've only got a single place to fix them. But I'm clicking on the email field. I'm setting the username from an environment variable that I have elsewhere. I'm clicking on the continue button. We talk about synchronization sometimes with our page objects, but certainly in Ruby, we're using something called Water as well, which is a wrapper around Selenium. So if you are using Ruby, I highly recommend either through the use of our solution here, Test Evolve directly, or through your own Ruby project using Water as a gem, as a library, because it gives you a very nice wrapper. So you're not necessarily dealing with kind of raw or native Selenium commands. But one of the great examples is this thing here, right? So I have my button, so my continue button, I've defined that at the top of the page. But I've got a stock command here that wait until that button is present before I then try and click on it. I could also make that be enabled. I could make that be .visible, for example. All right, so that's just one of the benefits of some of the wrappers that you can use, certainly with a Ruby and a WebDriver framework. All right, but the idea here really was that this was 5 lines of code now consolidated into a single login method. All right. So again, from a readability point of view, much cleaner. Okay, so if we just step through that test, so this was a full implementation of the page object model. we should see that this reads nice and cleanly, virtually like a manual testing script. Scores very, very high on the readability side of things. It scores as high as you can do on the kind of maintainability and the reusability side of things, right? So as a team, any other person on your team, when they pull down the latest version of the code, they will see that there is a results listings page. They'll see that there is a results returned kind of Boolean confirmation method. They will see that the add to cart button has already been defined. Okay, so very, very high on the reusability. Let's just check the readability, right? So the idea that this is a manual script effectively. So I go to the amazon.co.uk page. I clear the cookies banner if I need to. I search for a product. I deduce that the results page hasn't loaded unless results have been returned on the results listings page. I deduce or I raise an error that the product wasn't displayed unless product displays returns true on the results listings page. I select my product. I determine that the page hasn't loaded, the product details page hasn't loaded unless the product detail displayed returns true on the product details page. Okay, that was the alternative version that we looked at. Okay, I click on the add to cart button from the product details page when that element is guaranteed to be present. I click. I check that the basket is displayed on the basket page. I raise an error if that's not the case. And then finally, on the basket page still, I click on the checkout button when it's present. Okay. I check that the sign-in page is in the correct state by returning true or false for the page displayed as a method on the sign-in page. And then I have a nice consolidated login user method on my sign-in page class. And then finally, once I've signed in, I deduce that that hasn't been successful necessarily, or I've not been taken to the correct page, unless the page displayed returns true for that checkout page. All right, so that was a full implementation of the page object model within a Ruby framework. So we looked at 3 versions. First of all, we looked at a version that had no reference to the page object model at all. The kind of partial implementation was the second test we looked at, all right, and that was partial in the sense that it started to introduce the idea of page elements, so individual UI elements, where we actually declared them as page elements that we could reuse within our code. But what we didn't see in that version was the idea of methods, okay, that start to bring it all together. And that's what we started to see here, right? So this is a method on this page class. This is a login user method on this page class. All right, so this is really the cleanest, the kind of the most maintainable, and so you don't see any of these issues with bad readability or lack of reusability. You know, it scores highly on the maintainability perspective. Okay, all right, so we're going to move on, and we're just going to have a quick look at a JavaScript implementation of the same thing. Okay. Right, we're going to take a look at exactly the same thing from a JavaScript perspective. Okay, so still using WebDriver to drive the browser, still using Cucumber and BDD. As you can see here, the scenario, the flow is exactly the same, but we'll look at how this is written from a JavaScript perspective. This is the full implementation. Okay, so I've only got the one version of the test here. Here's my scenario. So let's start by looking at our steps. Okay. So, and we'll be brief here because to all intents and purposes, it looks and feels very, very similar. So we are going to open our home page here. So I have a separate method here on the home page that goes to amazon.co.uk. We have a clear cookies banner, I should say function really, not method, again declared on our home page because that's where we're going to see it for the first time. And this is the first time where we start to see the idea of element definition in a JavaScript framework. All right, so I actually, this isn't in a helper file in this particular project. I've declared it on the home page, but so we say this dot accept cookies. I'm using a CSS locator strategy. I'm using the ID. That's the value that I'm using as the ID to hook into that element. So I'm simply saying, and of course with JavaScript we have to deal with the asynchronous side of things. Okay, so await this accept cookies dot click. All right, and that's what's actually happening for my clear cookies banner method. All right, so stepping quickly through, you'll see we still have reference to our representative page classes as per the pages of the application under test. I have an equivalent search for product method here, searching for deck chair. That's on the home page. Okay, so it looks broadly the same. Search for product, we pass through a value. We're using our page elements that have been defined. So search field.click, search field.send keys, set the search term, and then search submit button.click. All right, so 3 lines of code consolidated into a search for product method. And then this was how we're using the page object to determine that the page load has been successful. So slightly different here. So we await the, we have a results returned method here. So in JavaScript, again, you remember what we were doing. We were simply returning true or false. So in JavaScript, I have the name of this function. I declare state. And I then say I await for this results section header is displayed. So if this is displayed, state is set to true, else state is set to false, and I return state. Okay, so that's the kind of equivalent way of returning that true file, that true or false, that Boolean value to determine whether that page is load. So results returned on the results listings page. If that's false, then I throw this error here. All right, so that's how we use that page object model in that kind of pure version, if you like. Here's a very simple method for the actual selecting of the product. Okay, so if I look at select product on the results listings page, select product, my function, await this my product.click, and of course my product was declared up here. In this particular case, I'm using an XPath because I want to work with the text value, and that was the long text value that I was working with. Okay, so stepping back, this is, I refer to the alternative way of kind of making checks on a page. So this is my verify product detail displayed function on the product details page. I can click into that. And this was where I was checking a number of things, all of which had to be true. Okay, so I'm checking that the product title is displayed, and also that the add to cart button was displayed, and also that the buy now button was displayed. If all of those 3 things are true, I set state to be true, and I return state at the end of that. So that is my verify product detail displayed method there, returning true or false. Okay. Moving down, verify that the basket is displayed. It's a kind of another version of the alternative method, if you like. So in this particular case, we're on the basket page, and I've written a kind of an encompassing function to verify that that basket is displayed. So in this case, I'm running this assertion within the page object. Okay, so if you remember, this is the alternative version that we talked about, where we're slightly kind of stepping across the threshold of potentially, you know, what people say the page object model should and shouldn't do. But in this case, this assertion is very much about the state of the application. All right, so I do think that's a completely valid use of a JavaScript function in this way. Okay, so we're simply saying if the checkout button is not displayed, then we will throw an error at this level. Otherwise, if it is, then we'll output the message to console saying checkout button successfully located. All right, so just like we did in the Ruby version. And then you'll see here, so we're going to click on that checkout button. Here is our kind of consolidated login user function. So await, sign in page, login user. And that's where we talk about, if you remember, we had those 5 lines of code using our page elements, okay, page elements on our page object. So our email field, our continue button, our password field, and our sign in button. We see these are all declared up here, just as we did in the Ruby version. Syntax, of course, is slightly different, but I'm using CSS locator strategy for all of these, and for 4 out of the 5 of these, I'm using an ID. In one of them, the page header, I'm using a class, okay? But the idea here is exactly the same, all right? This is a service. The login function is provided by that page of the Amazon website, and so I've decided to set this up as a function using my page elements to click, sign in, basic stuff. But yeah, this is a good use of the page object model, okay? Again, as with the Ruby, you know, if one thing about these, any of these elements changes, I just have this single place, you know, to come and fix the continue button, for example. If that ID ceases to be continue and all of a sudden is changed and it's now proceed, this is the only place I need to come to update the definition, our definition of what the continue button actually is and how we're going to hook into it using WebDriver, talking to the browser. Okay. Yes, let's just. I think let's just look at this from a readability point of view as well. So I think, you know, it scores just as high on the maintainability and the reusability. You know, JavaScript, maybe if you're not familiar with it, is you know, slightly harder to kind of read through as a new user. But I think you'll agree this still very much does read like a manual testing script. Okay, so open the home page, clear the cookies banner, search for a product, check that results have been returned, check that a product is displayed, select a product, check that the product detail is displayed, throw an error if it wasn't. This was the alternative, verify that product detail was displayed. Again, the alternative being that we tuck up our assertions within the page object itself, not as it is here within at that higher test level. We click on the add to cart button. We throw an error if the basket isn't displayed. That was the alternative form. Once we have our basket, we then click on the checkout button. We throw an error if we are not then taken to the sign-in page because we're currently operating as a guest user. So we expect to be taken to the sign-in page. We have our login user method. And then we throw an error if once we've logged in, we're not taken to the checkout cart page. All right, so it's just a bit of an insight into what exactly the same test is going to look like using a full implementation of the page object model using JavaScript. Okay. So, having looked through some of the code now, both Ruby and for JavaScript, let's just kind of really focus on these definite core benefits of the model. Okay, so top level, it's all about maintainability, reusability as a team of testers, developers writing this code. You know, we should be taking our automation code as seriously. We should be treating it as production code. All right, tests have got a job to do, as we say. Readability and then stability and scalability. All right, so I think as we've moved through those code examples, you definitely see that better code organization. All right, we understand that we've been separating out our UI elements, our page elements, defining them independently, single place to fix them. We've been separating them from the test logic. All right, so we were making test assertions with these Boolean methods or these functions that return true or false to tell us about the state of the application. Okay, we have a very modular code base as a result of that. We looked at the how straightforward it was to read through that test and see it read like a manual testing script. And we saw that we completely removed any code duplication. The first version that we looked at, within 2 lines of code, we already had element duplication because we were dealing with the way in which WebDriver instructs the browser directly. Okay, so as we said, if you extrapolate that across multiple tests and multiple team members, you are going to have 10, 20, 30, 40, 50, 100 places in your test project where you need to fix things if and when they go wrong. All right, so these page objects are shared across multiple tests, as we've seen. When testers pull down the latest code, they benefit from the building blocks, as we call them, that have already been developed by other members of the team. Okay, we saw the readability. All right, always keeping this focus on having an element of being able to step through your code like a manual testing script. Okay, always trying to use descriptive, meaningful method or functions. Certainly helps team members to kind of get on board with the process, and that goes exactly the same for the way in which you define your elements as well. If it's a add to cart button, then call it an add to cart button. Okay, if it is a username field, then call it a username field, or a submit button. Okay, call it what it is. And then when you have as we saw with our login function, when you have a function or a method that uses those elements in sequence, it all wraps together nicely and makes a great deal of sense. Okay, stability and scalability. Yeah, scaling as in terms of adding to your test pack, refactoring your tests and adding to them over time, over a series of sprints. You're going to want, we're assume that most people are working in an agile way now. This full implementation of this page object model like this is going to power you through these kind of these agile sprints. You won't fall into the trap of having these mini waterfall cycles where testing and test automation specifically is struggling to keep up with the development effort. Okay, when you implement this, you will stay on track. You will be in the same sprint. Which is a great place to be. And fundamentally, it's what we're saying here. Okay, updates to the UI, and again, updates can be a bug. All right, it's an unintentional update or intended updates, but breaking changes, as we call them. When you've got your code structured this way, they won't impact the entire test suite. All right, you'll have a single place to go and fix them. You squash that maintenance effort to a minimum. And you stay on top of any particular failing tests. And that's ultimately, as a tester, and you come in the next day and you see a build with failing tests, that's what you've got to do. You've got to understand why that test has failed. Either it's found a bug, or the test itself needs to be refactored or potentially retired if that functionality is no longer there within the application under test. All right, so these are absolutely the core benefits, and I think we've seen that as we've walked through the code. Okay. Any potential downsides? Well, not downsides, I would say. I think things to be aware of, and that the spoiler here is that the benefits of everything we've looked at far outweigh these initial humps that you may come across. All right, so yes, there is some initial development time and a learning curve, but test automation isn't easy. It's we take it seriously like our production code. It's an investment of time and effort. It's upskilling your team, but you can get on board with this very quickly. Certainly, if you choose to start working with a language like Ruby or Python, I would say that learning curve is minimized, as much as it can be, because these are great languages for manual testers or people that have not spent a great deal of time writing automation. They're great languages to get started with. All right, so. But be aware, there's, automation is hard if done right as well, if done properly. You'll reduce the maintenance, but it's still a challenging topic. Okay, so you have that initial learning curve. Synchronization, you saw me refer to things like wait until present within the Ruby version. Okay, so it's really just the concept that, and it's slightly more challenging with JavaScript because of the asynchronous nature. But with the Ruby example, we had to wait for a button to either be present or for it to exist or it to be enabled or to be visible before we try and do something with it. So the page object model certainly helps with that. It doesn't fix everything because at the end of the day, we're using a tool like WebDriver to interact with the browser. Okay, so we do have to code defensively on occasions to make sure that things are in the right state before we try and do things. But we try and do that dynamically. We don't just add a whole bunch of sleep statements. We make a dynamic check that tells us whether something is in the right state before we choose to proceed. Okay. And then, yeah, okay, you will see a slight increase in your code base size when you do implement this. But again, I think the benefits of a clean, maintainable, reusable, readable code base far outweigh any potential kind of size increase. This is an automation project, and what we're talking about here is widely considered to be best practice. Okay, so these are things, in the area of transparency, these are things to be aware of, but I really don't think that any of these is a reason not to fully kind of invest in the use of the page object model. Okay. There are some alternatives out there. I'm not going to talk at length about them, but you could go away and Google these to your heart's content. All right, so we have something called the screenplay pattern. There is action-driven testing. Keyword-driven testing used to be a very, very popular topic. And then most things, in truth, are kind of a hybrid approach. All right, data-driven and keyword-driven testing. To some degree, if you're using a page object model, you are using keywords really, because you have a page class and you have a method name or a method or a function that you're calling, and that's almost like calling a keyword. When we use Cucumber with example tables, we're actually then data driving our testing as well. So there is some overlap between these alternative models. Okay, and I think in general terms, so right. It's reasonably self-explanatory now, but if we don't use a model like this, what are we at risk of seeing here? Well, we saw the code duplication almost immediately. Okay, we had 2 interactions with a particular field on the application, and that will be considered duplicate code, right? So if that broke, there were immediately 2 places we had to fix that. So if you don't implement a model like this, you're going to have that aspect of code duplication. Which very much leads on to the idea of fragile UI tests. As we stepped through that code, we saw how the readability improved. Okay, so when we moved from just browser-based interactions to page element-based interactions, and finally onto page element interactions and methods that bundled things together, that was the ultimate form of readability. So you can see that when you don't have any of this, you really don't have that readability. That learning curve for a new team member is going to go up because it's just not going to be as readable. With higher levels of code duplication comes lower maintainability. All right, so you definitely you run the risk of falling foul of these things. Absolutely no reusability at all, really. We saw that so if someone needed to complete that sign-in form, different testers, different tests, that sign-in form functionality will be duplicated, but it won't be reusable. So you don't have the benefit of that. And all of these, I think, in combination, really. The concept then that you could remain effective and on time within an agile sprint, I think a lot of that goes away if you don't use a model like this. Okay. Cool. So I just thought I'd finish up just dispelling some common misconceptions about the page object model. Okay. And I think we've probably looked at some of these today, but yeah, firstly, so page objects are only for pages and only for one page object per page. Definitely not true. All right, so as we say there, all right, page objects will represent either the page itself or a logical component or section of a page. So an example of that might be if you've got a substantial header or search function on your web application. Some of the sites you see nowadays with these mega menus where you can do a lot of stuff on there, that would quite easily warrant its own page class in your automation project. Okay, so yes, they can encapsulate components, widgets, sections of pages. Okay, another common misconception: page objects are just wrappers for elements. Well, we certainly saw how we declared elements within our page objects, but actually above and beyond that, we saw how we used our page objects to return true or false when we were checking state. Okay, either on a single thing that we were checking or a combination of 2 or 3 things together. So we were using our page object and a particular method or a function within that to tell us about the state. And then at a higher level of abstraction within our tests, we would then have the ability to raise an error based upon that correctly being true or otherwise being false. Okay, so it's not just about declaring your UI elements, although typically that's where we start. Okay, it's definitely not only for Selenium. So as I said at the very beginning, whilst this was from the late 90s through the early 2000s onwards, understandably this was heavily adopted and advocated by the Selenium community. But as we saw, it actually came from, it didn't come directly from Selenium community. It was adopted by them but didn't come from them. As a result, it's a concept that can be applied to many other frameworks as well. Okay, so if you are if you're using something like Cypress or Playwright or Puppeteer, yeah, absolutely. Look at a page object model within those frameworks as well. The benefits are there. It's agnostic to language and also to type of framework or to whatever you're using to drive the browser. Okay, so it's not. It didn't just come from Selenium, and it's not just to be used on a Selenium project. Okay, we looked at synchronization, so waiting for state on buttons, for example. So yeah, the idea that a page object model eliminates that need for checking state and waiting for things to be in the correct state before you proceed. It helps, as I say, but it doesn't go away. All right, so and that's in the Ruby version. We had this thing like wait until present, for example. So different languages and different wrappers will offer you some help in that regard. But yeah, this will help, but not eliminate, and that's for sure. All right. Yeah, and then as we said, this didn't come directly from the community. Okay, so it's been around since '99, but as I said at the very beginning of this, in no way at all. It's plus 20 years now, but in no way at all does that diminish any kind of value that we get from this. All right, so the majority of coded automation projects, successful automation projects, will be using this to some degree. All right, and we looked at a couple of different levels of implementing of it, but done well, done the right way, with the right intent, with the right team members adopting it and embracing it, you will set yourself up for the kind of the best level of success that you can achieve. Okay. Good. All right. Well, I would just want to thank you very much for your time. If you'd like to explore any of this in any more detail, I've been using TestEvolve Spark for what I've been showing you today. So we support Ruby, JavaScript, TypeScript. Certainly I've shown you a couple of those this morning. You'll find us at testevolve.com. By all means, look at our GitHub pages. We do have a 90-day free evaluation. Okay, so why not come and join our community? Yeah, we'd love to hear from you. So thank you for your time. There'll be many more webinars to come, and I look forward to seeing you then. Cheers.